thank you everybody for coming out tonight. This is the first night after fall back, so it's a little bit extra dark for us, and it's always harder to come out when it's pitch black outside, as opposed to when we have the nice sunsets. A couple of quick things before we get started with James. The last 3 AWS community bags, if you guys want them, please feel free to grab them. Make sure that you grab a feedback form to let us know how we do, and additional things that you want to see in the future. Speaking of AWS Community Day, all of the videos have finally been posted up onto the YouTube website. So if you go to YouTube and put in AWS Portsmouth User Group, then ours is the channel that'll pop up. I set it up as a playlist in there, so you can just go through the entire day, starting with AM and finishing with like Brian Tarbox and those guys. The videos came out really good. The video production company that we hired to do it actually did a really good job, way better than my little tiny camera here. They've actually like superimposed the slides over the video, and they fade in and fade out and do all kinds of really cool stuff. So check them out. Also the Twitter handle AWSPUG. If you guys, we're going to start trying to add all of our content and updates and all of the new information that's coming out. We're going to post it there first, just so that we can keep everybody up to date. And I will be responding to questions on it, so if you guys aren't on the Slack channel, and I've been horrible about adding people to the Slack channel, so A, hit me up if you want to be on it, B, go to the AWS Bug Twitter handle, and I'll also be responsive from there as well. What other information?
What is the Twitter handle again?
Huh?
What is the Twitter handle?
AWSPUG.
Okay.
Amazon Web Services Portsmouth User Group.
Mm-hmm.
It was actually available, so that was pretty awesome. So, and it's got the little screenshot of us in there, so you'll know when you see us. Okay, well, with that, James is going to talk a little bit about serverless and a year of bumps and bruises and warts, and I'm excited to hear about it. So, take it away, James.
Sure. Yeah, thanks everyone for coming. I know it's a dark night and it's better to be sat at home hibernating, watching Game of Thrones. So I do really appreciate it. So my name is James Beswick. I'm the co-founder and CTO of Indevelo. We're a small shop that builds solutions for customers. So in addition to those roles, I do everything else. And we've been using serverless for about a year. We've been in business about 3 years. And typically, most of our clients are venture capital funds in either Texas or the UK, and we do work for people they're investing in. So we have a kind of odd business where we generally build MVPs for people. And most of what we've been building has been one form or another a web app, things I didn't particularly want to be building when I started this business, but it turns out that everything is a web app these days. And so after the first couple of years of building this, about a year ago, I started to notice some patterns happening in what we had. We had many apps, and they all had similar structures. We've been using AWS for a long time, so we've got EC2 instances, we've got elastic load balancers, we've got RDS, and they're all basically the same packages of stuff that we have for each app that's out there. And we end up having to patch and manage and look after these, even for things that have been dead for quite a while. We ended up with multiple languages coexisting. Primarily Python was our weapon of choice, and then more and more JavaScript was coming into it. And it became difficult with some of the Flask middleware we were using to handle JavaScript and everything else that was there. We were starting to see a lot of duplicate code. So you write a few of these apps and you realize it's the same boilerplate over and over. You're doing authorization, database management. A lot of the things we're doing is SaaS, so there's a lot of multi-tenant stuff in there that you don't expect to be writing when you first start. And most of all, we found from the client side this inability to scale. So we're building MVPs. Most of these things never see the light of day. Most of them fail. Most of them die. Some of them actually do hit. And the problem with this is you're building an MVP to do the minimum, but then when it takes off, it's not enough. And you end up scrambling to add features, make it scalable. And you kind of look pretty bad because it doesn't really work that well. On top of which, our clients started to change. So initially when we were working with AWS, we're getting a lot of stuff for free. We look really good, like we're rock stars. But most of our clients now know that AWS does a lot of these things for us. So they're asking for more and more things, especially on the front end where they want to see real-time performance. They want things to really look like Facebook or Google, even though those guys have thousands of engineers and my team is basically 5 people. And finally, there's this second inability to scale, which is managing old apps, which I've sort of touched on a little bit, but actually starts to haunt you because you're just maintaining things you've been paid for, and they're starting to take more and more hours in your day, and you're too embarrassed just to let them fail. But what do you do about these things that are out there? How can we scale as a business for the next 2 or 3 years if we have to manage the other few dozen apps that have gone in the past? So what happened? Well, I went to ServerlessConf a year ago, thereabouts, and really didn't know very much. I knew that serverless can be used for resizing images. That's cool, I guess.
JavaScript.
Yeah, and I didn't really know what was going on going in. So they had a few workshops where this was kind of enlightening because we could build some video sharing websites and some chatbots and meet some of the people who actually had used it at a production scale. Ben Kehoe, who was here a couple of sessions ago from iRobot, I mean, this man has a fleet of robots running on serverless, which is pretty neat. And then you start to realize at a production level, lots of people are doing lots of things. So many of the questions I had before going in really got answered in that environment. If you get rid of this server, where does the functionality go? What about auth? That seemed like a big mystery to me going in there. Where's state going? Who's building this web page? And if I take my server away and I throw things at Lambda, then what happens? And so, probably the biggest question of all, of course, is what the hell is serverless? And it's still a question I get asked all the time. Usually met with the obvious thing that there are still servers and servers. So then we got all excited and we started building things. And we had some real failed attempts. So we got out of the gate, flew back from New York, we're all excited, got into the Lambda IDE, and started to hate my choice of career really quickly. Then we hit the we know absolutely nothing about this phase. So we started looking for documentation. Well, good luck with that. Then we went through tutorials, training. We started to find some real landmines with RDS. Just doesn't work the way you think, and I'll get to that in a little bit. I had a minor success. I had a cron job that needed to run, and I managed to build a Lambda script, and it did it. Woohoo! So I then got a bit too ambitious and tried to do a few more things. It didn't work at all, and I'm back to, well, this is ridiculous. So I basically then booked out a weekend, and I had this little Python app that is a recipe site. And I decided this would be a great example to take this recipe site that no one's paying me for, and it's not really embarrassing if it falls over, and move it into serverless. So I did a little bit of research. I found Zapper and Chalice, which are basically 2 tools you can use to move Python into Lambda. Total disaster. Essentially, lots of errors, lots of problems. It didn't do anything. Then I got into the auth problem, where my existing site had this really neat little Twitter button. If you press it, I know who you are. I immediately have your ID, and we're ready to go. I start getting into Cognito. Ooh, Cognito. There's no Python examples out there that weren't a year ago. And it's really like using a sledgehammer to crack a walnut on this problem. And more I started to realize this lift and shift doesn't work at all. You have to essentially rethink the whole piece. And the big thing I missed there is RDS. So what they don't tell you is RDS does not work with serverless. Now, let me caveat that before anybody says anything. Technically it does. You can run a Lambda inside a VPC, put in a NAT gateway for $30 a month, yada, 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 yada. The problem is that if you have any sort of scale on your app, the database isn't going to like this because the connections don't work that way. So until there's an HTTP endpoint on RDS, it isn't really something you can use at scale, which means you're into DynamoDB land. So we took some of those lessons and we started playing with some very simple client work. And we found over time the architecture shifted. So in a really simple example, this is what it was like before. You've got an app, there's an elastic beanstalk application, talking to RDS, all living in the VPC, beanstalks creating all the content, really simple. The next phase was the Lambda as monolith, where all you're really doing is treating a function as a server. You're just stuffing a function with everything you can think of. And you're doing it wrong, but it seems to work because you can use sessions in there and all sorts of things that really are terrible ideas, but it does actually work. Then you get to the point of the middle layer and realize, well, I need to start breaking this apart more. And So we went down this in the proper way, and we came up with our REST infrastructure and different lambdas for business logic. And then I started to think about JavaScript really differently. And coming from Python, I didn't know JavaScript very well at the time. And I started to jQuery myself to hell. I mean, basically, I had things going on in these web pages where Flask is returning code and there's JavaScript everywhere. And it was scary. So I fixed the front end. And in this case, we used Vue. We could have used React. I just used Vue because it was easier at the time, and you can really learn it in a day. And this solves a lot of your problems, because essentially with Vue, it lets you treat the browser like a desktop application. So now the browser can manage all your state, all your interaction, and a lot of the jQuery problems, just all of them really disappear. And all of this gets served from S3 through CloudFront. So now you're starting to get much more of the serverless feel to the whole thing. And finally, we said bye-bye to RDS, bye-bye to my $30 a month bill I really didn't want to pay when everything else is costing nothing. And DynamoDB, if you come from RDS, which I realized I've used databases my crutch my whole life. I've been stuffing things into SQL Server and MySQL, letting it do all the hard work. And when I stepped out of that, I realized DynamoDB isn't like other NoSQL databases. It's not like RDS. I'm not even sure what to compare it to. So you have to suddenly start learning how it works. So what did we learn? So out of that whole thing, there were 6 core lessons. So the first was get your tooling right. Lift and shift didn't work. We came from Python. We ended up not writing any more Python ever again and shifting to Node. A sentiment that may be very popular on the internet, I can tell you. And essentially, a lot of this came down to playing with different tools and seeing what fits. So we build web apps, and that's obviously not the use case for everybody, but we found certain tools fit really well with serverless, whereas others don't. The second part was to get rid of this middle layer. And psychologically, this is really hard because we've had servers for 20 years or so, or at least I have, and we kind of like them. You know, they're pets, they're cattle. You know, we log into them, we patch and maintain them at the weekends, we feel we own something. And so getting rid of this piece, where it's your baby monolith you're building, is actually kind of a hoop to jump through. Then using a SPA, a single-page application framework. So although this isn't strictly anything to do with serverless, it just happens to fit into it hand in glove like you wouldn't believe. So a lot of your front-end nightmares go away when you get into this environment. 4, learning to love DynamoDB. So DynamoDB, you know, it's so simple, it only takes 6 months to learn it apparently. And what you find with this is you go through a lot of iterations with DynamoDB. It's completely unforgiving. If you mess up any part of your design, you end up tearing it down and starting again. But one of the things it does have is it's got basically single-digit millisecond latency on requests, for most requests anyway. And it also allows you to attach events to changes in data, a little bit like triggers in a database, but much more powerful. And this was the light bulb moment for me, because I realized I could hook in things to DynamoDB, and it became part of the decoupling part of the infrastructure. So I could bring RDS back, because in some applications where we have analytics and things where we really do need some other type of database, I could just feed it off the triggers from DynamoDB. So that was a great moment when I figured that out. And finally, authorization really is your friend. So, you know, we came from the business where you're handling usernames and passwords going through a server, and now in this space you get into JWT tokens. Well, if you've not got into this before, this is a brave new world. So essentially you have a token that's given to you, and you decode it very quickly, and you have an ID that comes out of it. And this is a little bit weird, because actually, although it's very complicated when you read about it, you're talking about 20 lines of code here and there that do all the heavy lifting. And it turns out to be pretty secure and fairly reliable, but most of all, it's very extensible. So when you want to add other services, you don't have to suddenly rewrite your logic where your auth is being handled. So that was an unexpected benefit as well. So I packaged all this up very excitedly into this article I wrote for Cloud Guru. 6 things I've learned in my first 6 months using serverless. and it went viral. So first thing I've ever written that went viral in any way. Thank you. And the internet responded. These are the polite comments. My favorite, 2 paragraphs in and I want to slap this guy. My God, this article is written like the author has just joined a cult. And he went on from there. So feedback wasn't generally positive out there. This was about 6 months ago. But you know, we're in the business of building things for our clients, and ultimately, you know, I pay my mortgage based upon how well we do that, not what people on Hacker News think. So our first serverless app experience. We built this application called Member Checkin. And this was written in Python when it first came out. And essentially, it was a way for businesses with memberships, gyms, museums, Costco, this kind of thing, to recognize their members instead of using cards by using their faces. And it works by using recognition. It's simply a wrapper for recognition. And so we built this, and it was launched in the UK and tried in a couple of locations. It worked fairly well. So what we found was, as any of you work in startups will remember or recognize, is that our client changed his mind completely about what this thing was supposed to do. So Member Checkin, if you go there now, it doesn't exist. That's why I can tell you about it. So the first thing is that it's a Python RDS recognition app that runs in a desktop browser. So if you go into a museum or somewhere, there's a receptionist and they have a machine with a camera and you're looking at the camera. Well, not anymore. Version 2, we're going to be changing it. So initially it took about 3 seconds to do a facial match. The new challenge was to do it in under 1 second and have a real-time UI on the front end. And so now it has to work on the phone, take a photo, and do the whole process in under a second, which actually is suddenly a major leap because we were taking this picture off the camera, uploading it to our Python server, doing some processing, moving it to S3, giving it to recognition, bringing it all back. And I had no idea how we were going to do this initially. What we did to get around this is we started using AppSync. And AppSync took out a huge amount of the code we had in the whole application. And now suddenly what we could do by using View is that we could process the image on the phone, make it much smaller, do a direct upload to S3, give recognition this tiny image and get it all straight back. And it came in at just under a second. Finally, our client, as clients tend to, decided to do a pressure test without telling us. So previously, we'd only tested this in the most informal environments where if things went wrong, it's not really a big deal. They had an idea that this could be good for concerts where people have tickets. And all you would need is have bouncers on the door with their phones and just scan you on the way in. So they did this. They had 12 people with their phones and nearly 1,000 people at an event. And given the time difference in the UK where this was running, I'm sat here and suddenly my Slack starts to go crazy because things are happening in the infrastructure I'm not aware of. And I'm starting to see over 1,000 people being checked in through this system. So it was a massive success. Unintentionally, it worked and it scaled without us ever planning any scale whatsoever. And we were getting ready to launch this under a different name and different package. And then GDPR happened. And basically it got shut down because we weren't sure if someone standing behind you had given their consent for the photo or if there were people under the age of 13 involved or anything like that. So my company ceased to be involved with the project and I don't think it got taken any further. So let's do a demo. Today I'm raising the stakes. I have a brand new laptop where this is day 1 of its usage and we're going to try and do a demo on a foreign Wi-Fi network that I've never used before, so let's see how we go.
What could go wrong?
What can go wrong?
Don't say that. You're jinxing him. Murphy's Law.
That's my job.
Murphy's Law might
is to
kick
jinx
in,
demos.
you know?
If you're crazy enough to do a live demo around me, demo but Chris.
I have no idea how to minimize this screen.
Window and D, if it's Windows.
Ah. I'm a technology professional. That's right.
Do you want a chair?
Oh, that'd be great, actually, yeah. Okay. So we're going to cheat slightly here. This is a location-based app, and instead of showing you my phone and making everybody peer at it, we're going to make Chrome believe it's my phone. Oh, thanks.
That's sale on your house show. I can't.
Sensors, that's what I'm looking for. Hey, success, okay. Okay, we got there in the end. So we had this product called Rated 5. There was a concept given to us, and you can see a little bit of it here. So the idea is that for businesses that have locations, clients come in, restaurants, hair salons, anywhere, and customers have an experience. And it enables the customer to give real-time feedback about what's going on. Was the meal good? Was the music terrible? Did the service suck? And the way it works is that you pull out your phone, go to rated5.com, it figures out where you are, and you get a list of questions. So we had a week to build this application. And this was in our post-serverless environment, where now we were using Vue and using this other stuff. So what you're looking at is the mobile app part of this, where I'll make it a bit smaller so you can see. So right now, I'm at a location. I can provide feedback about the various factors that have been preset. Food was great. And I can take a photo. Sure why that doesn't work, but and then it sends the feedback. There's a second application that the business logs into, and they can see their consolidated feedback. And in this is they would go in and configure. They can say which locations belong to their business and what sort of questions they want to ask about the service and so forth. And all of this is fed through to a dashboard. And when feedback comes in, it pops in real time into the dashboard. And this is kind of a neat application because it's the first one we produced where we pulled it all together and actually knew what we were doing. And it took 5 days to build both applications. We spent 2 days on the mobile piece, which was tricky. And then we spent a couple of days on this back end just to get a look and feel that looked reasonable with the animations and various things. But the plumbing of it was really done for us in serverless. Don't tell anyone. So when you look at how this works, and it's really, the app itself is very simple, but in terms of the architecture, it's not really going to make me start at the beginning, is it? Yeah, of course it is. Almost there. Okay, so it looks like this. So this obviously is really alien if you come from the traditional application world, but it's kind of normal in the serverless space, and I've actually become very comfortable with this. But in the case of this application, a user submits their ratings, it hits the API gateway. There we can do some stuff. We can make sure that you're not a bad guy, that you're not spamming us, that you're not somebody we don't hear from. We give it to Lambda. Lambda then takes the record of the score that the user submitted and puts it into DynamoDB. We then have some additional logic. So I don't know if you saw on the screen, there's a thumbs up and thumbs down. So when in the comment we run a sentiment analysis on the comment, that comes from AWS Comprehend. Then we hand that photo that we could take back to recognition, just to make sure it's not something inappropriate. And finally, the whole thing gets notified through SES back to the client. Each of these things run independently, and they update DynamoDB as they need to. And then the real magic is that in a regular application where you're sending out the requests from the browser and waiting for the whole thing to come back, you don't really need to do that at all. We can get all the results back through IoT. So you might have heard that in serverless, we can't do WebSockets. Well, you can because you use IoT. That's the way you get around it. But this means that the application, when it loads, you're just loading these assets from S3. The application's sitting there in the browser doing nothing, just waiting for IoT to tell it when new ratings are coming through. And so these are kind of the nuts and bolts of serverless as you start to play with this. And more and more of our application diagrams start to look like this. And on the one hand, it feels very simplistic. And on the other hand, what this doesn't show you is it's massively scalable. So we did a test on this application where we used Lambda to basically sync ourselves with thousands of requests. We turned off the email. And it actually keeps up just fine. And so, this again was something where we first started doing this, we weren't really expecting that to happen. So it's all great, right? But there are some issues, and they're not technical. So in the development side of things, there are some challenges, and I've seen this with the groups we work with. You have to learn to decouple absolutely everything. And you've got to look anywhere where you think there's a monolith building or starting to build, and see if you can rip it apart some more. Don't be afraid of SQS. It's fantastic. Put it everywhere. Put it between absolutely everything, and then argue why you should remove it from somewhere, not the other way around. It's practically free to use, and it does some amazing things for you. Functions need to be decomposed further all the time. If your function's running more than 20, 30 lines, why? What are you doing? And I'm the biggest culprit for this. My functions get to be enormous, and I keep trying to throw things in. And I've got projects running in VS Code, and I don't like the idea of having multiple projects. And I'm a huge offender with this. You need to basically bring down these functions down to doing one thing really, really well, and only that one thing. And what you find with this, if you can do it well, is that you can reuse code. Remember that holy grail? You can actually reuse code. If your function, all it's doing is sending an email or processing an image, no problem at all. Log everything. So, space is cheap on AWS, so don't be afraid to just use everything. X-Ray is a great tool, Splunk's great if you have access to it.
Have you used AWS step functions?
Yes.
That is the orchestration, then you don't have to do a lot of this plumbing because that comes in built in, right?
So step functions is an excellent tool for long-lived processes. Things like order flows that might take multiple days with deliveries and things happening. For short-lived things where you're going through a series of motions, it can be overkill and it's expensive to use comparatively. But if for the right purpose, it's fantastic. Yeah, absolutely.
Have you used it?
Yes, we had an order process we used it for, and it managed a third-party credit card process that went wrong frequently.
Okay.
And previously we were using DynamoDB to manage the state of something that was going on, and it didn't work very well. So step functions is really good. Bake-in security at the beginning. IAM, people frequently misuse this. There's too many, broad security roles given to things. It's easy to do if you have developer accounts. You're like, oh, I'll just give myself access to every S3 bucket out there. Then you never fix it, and it goes into production, and then it's not secure anymore. Training and learning. Everybody is new to this, all of us. So, don't be afraid to say, I have no idea how this works. I'm still learning this stuff. My team's still learning it. it's great to take on some of these projects. Like Serverless is doing a no server November. They've got some interesting challenges. You can win a t-shirt. But more importantly, you can teach yourself a few things. And then find the yay-sayers, not the naysayers. So I had this with cloud, and I got into it a few years ago. You're not going to convince people who don't want to be convinced. You know, when I first worked with cloud, it was like, well, no one's ever going to use that. It's someone else's data center. It's not secure. Avoid those people. Work with the people who want this to be a success and want to find better ways of delivering applications. Then you have the organizations. So inside the organizations, if any of you who work for larger companies will be familiar with the great IT wheel of excuses that get spun every time somebody introduces something new.
Be careful, because half of these guys are from Liberty Mutual and other IT companies.
Hey. Bring it on. And this is fairly normal, but these are the top 5 excuses, or not excuses, reasons I've heard why we don't want to do this thing. I don't think we'd ever need this. I hear this all the time. And that's, again, because we've done actually a poor job of explaining to the world what serverless can do. Image resizing, great. Where are the other examples?
So, you know, the funny part of it is, when mainframes existed, they were essentially serverless. They were doing queuing, kicks and all, essentially were kind of serverless. Sure.
And the thing is, I think as companies realize the tasks they can take over, I mean, almost any asynchronous task is a candidate for serverless. You know, how many companies have cron jobs that are running, reports running? There's a server somewhere that someone's babysitting. These are all things that they can do. So when I hear this, I have a generally good response to the question. The second one is, this is just like time sharing on the mainframe. And it's usually along the eye-rolling phase of like, oh, you guys, there's nothing new here. You know, first it's cloud, now it's serverless. What next? And that's not true. So, yeah, time sharing, it's kind of like that. You know, you can share resources, not pay for idle. Isn't that wonderful? That is the smallest reason why you should use serverless. In this world, there is no 100% CPU. Their scaling is done for you. And this is just epic. I mean, fundamentally, what other system do we have that works this way? So, although people like to focus on how it's a really great use of CPU time, and actually it isn't. If you look at most applications, we do a lot of repetition and duplicate tasks all the time. It's really the scale on the other side of it that's the benefit. But what about vendor lock-in? So I hear this from companies, usually ones that have multiple-year Oracle contracts, Windows in every desktop, and no diversity in the IT infrastructure whatsoever. And they say that with a straight face. So first it confused me, but really the question is there a trap here? You know, are we putting all our eggs in one basket? If AWS suddenly ramps up the cost of Lambda, you know, what do we do? I don't think this is a real concern. You know, with frameworks like serverless, these agnostic frameworks where you can pick and choose, you really do have the choice to move things around. There are plenty of apps out there that do run functions, grab things from Firebase, don't do that, and you know, come back to Azure. It's absolutely possible. So in my mind, mostly this comes down to the way of finding fault with something for a virtue that pretty much all software has, because every type of software that we use has some form of vendor lock-in. My team / manager / boss, cat, dog, spouse won't like this. And you know, part of this is actually more to do with the fear of my job. Because Tom McLaughlin has this fantastic presentation, I don't know if anybody knows him, he has Serverless Ops in Boston. Runs this slide and you can hear the air leave the room. Get rid of your ops team. And it really is an attention grabber, he doesn't believe that at all. What we're saying here, actually, is not get rid of your ops teams. Remember when cloud first came out, we said the same thing. Oh, we don't need all these guys. The dirty secret of serverless is actually the opposite. You don't need your dev team. Because serverless is complicated. And the best people who understand it are actually the ops people who know all this works. And certainly in my experience, I've found the people who understand the back end, they find the front end pretty easy. Not the other way around. The front end people are not replacing the back end. But we keep that in our back pocket. We don't want to alert too many people. It isn't early. It's too early. Serverless isn't ready yet. This is another one where the idea is that serverless has suddenly jumped onto everybody's plate, but it's brand new and it cannot possibly handle all the work we want done. Well, serverless is 4 years old. Lambda's hit its 4th birthday this November, and certainly there are lots of production workloads running in this environment. And of course, it's not just functions. So if you think about CloudFront, S3, these are things that handle billions of transactions a day very reliably. Lambda, we're starting to see more and more companies that are coming forward and saying how they're using it. I've listed a few here. Some of the ones I think are interesting. iRobot, I mentioned, uses a 100% serverless environment with all those little robots you have at home. That's pretty remarkable. And even Netflix is starting to use this pretty dramatically, and so is Amazon. So there are a lot of production scale examples out there. So finally, just some thoughts for you, because it's been barely a year we've been doing serverless, and it feels like a lot longer. I didn't think this was going to work, quite frankly. I'm a huge positive advocate for technology. If it's Bitcoin or something, I'll jump all over it and have a look. Most things just don't work out very well. I can't really turn them into usable things for my clients and make their lives easier. So we're still in a little bit of a state of shock, but the reality is it's worked really well. This is all very new, and if you've not been involved with things that are right on the coalface of discovery, everything's a bit different because the patterns and practices are still being discovered, and things change frequently, and they're getting better all the time. But don't buy any books on the subject. Listen to people on Twitter. There's actually people there who educate the world on serverless far more effectively than you'll find by searching for books which are bound to be out of date. Don't hate on containers. So the tech holy wars, gotta love them. Apple versus Mac, JavaScript versus Python, you name it, we can find an argument and a dispute to have with people. Well, right now, there's the serverless versus containers dispute. Who's gonna win? Well, serverless does use containers, and in reality, both of these solutions are a natural evolution away from the server. We're both right. It's just serverless is more right.
Was it a biased answer?
Yeah. And follow the leaders. So I put together this Twitter list because I was starting to find there's about 20 or 30 people who I think are really smart in this space. I'm not the world's best developer. And just like there's always somebody you find who's better at JavaScript than you are, there are people who are better at serverless than I am, and they all seem to be on Twitter, which is fantastic. So I set up this list, and I go on here every day, and truly, I learn more from these people than anything else. So thanks for listening. I hope that was useful, but if you have any questions at all, I'd be very happy to take them.
Good stuff.